I would like to emphasize that we're moving now to what I am more comfortable with, which is the uncertainty of living organisms. And the next speaker is Gary Sharp, who's a marine biologist. The reason I say it's important for you to recognize the difference in a viewpoint that I have is I look at the world as a relatively living organism that's dominated by negative feedback mechanisms. Negative feedback mechanisms for medicine make it possible for me to be as dumb as I am and still take care of people. Because you have to understand that a person who gets sick, even if they are sick, it's on top of what amounts to a very, very clever arrangement that's made by somebody that keeps them alive all the time. The world is sort of like that. So Gary's going to talk about marine biology from the perspective of the current debate. I hope that'll cover a decent introduction for you, Dr. Sharp.
Well, the good news is I spent the front half of my life living in a fishing family and listening to and meeting and understanding what little old men tell you about how to survive in the real world of maximum dynamics, which is the ocean and atmosphere they live under. I ended up getting a PhD in population genetics. I'm a physiological biology, physiological ecology, geneticist background. And my first real job was going out into the open ocean, measuring vertical profiles of the temperature while testing the sinking rate of a new fishing net that was introduced into American culture by an Israeli master fisherman who managed to escape Poland back in the 30s. One of the tricky parts of taking animal physiology into the real world is you discover it's all about locale, geography, physical features, and the dynamics that every critter undergoes. Plants and animals are pretty much kind of stuck. Animals that live in the ocean are busy. They get up and boogie. And part of the problem we have is that all this leads to fuzzy ecology. You have to pardon me, I do know how to make sharp figures, but that's the message. The ocean is very complicated. It starts with a bottom-up process where things flowing in from various sources create nutrients, phytoplankton, bacteria, worms eating the bacteria, other critters bringing it all together, and it floats up into and gets transferred up into this major species of food organisms that we happen to harvest. And the bottom line is this busy stuff down in the middle is nearly always missing or at best guessed. Remind you a lot of climate models? The other problem we have is the sun really does play a very important role, and cloud cover modulates sun, and which indeed changes the primary production rate, also affects wind speed and directional intermediate. It affects the upper ocean currents and food distribution and vulnerability to fishing gear, believe it or not, which is what I spent the front 10 years of my professional career looking at. And then temperature is the basic physiological controller for everything in the water column, and us. In La Jolla, where I first started my professional career, there were such an amazing group of empiricists who were trying to get answers and the right questions and the right answers to those right questions. Among them was John D. Isaacs, who started off as an albacore fisherman in the 1930s and evolved into a geologist, paleosedimentologist, and he had system thinking in his mind. And I look at my world as applied science, not goofball laboratory science, and part of it is due to people like him, Reuben Lasker, and a huge array of people who were in the La Jolla Fisheries Laboratory and at Scripps Institution at the time. J.D. Isaacs inspired a young student in the late 60s and early 70s, Andy Sutar, to take a sediment core in the anoxic Santa Barbara Basin and spend the next few years counting fish scales, sardines and anchovies particularly because of the major historical perspective in California and other parts of the world, and plotting it out on a similar time scale. What you discover is that there's about 40 peaks and valleys for each of these species, and we know that the anchovy basically depends on strong upwelling for its population growth, and the Pacific sardine likes warmer water. So we have two opposite responses by organisms actually inhabiting the same environment. The oldest documented fishery in Western culture is in the Straits of Messina, and it's a harpoon fishery. This happens to be a vessel that I was on board in 1981, and the fellow at the top of the mast there is actually the skipper, and he has the controls and has complete visual access to everything at the surface. And there's a little guy standing at the base of the bowsprit there, and he's got the harpoon, and when the boss tells him to go out there, the boss will actually put the bowsprit over the animal, he'll poke him, and they take him home. And that's been going on for 2,000 years. This happens to have 2 diesel engines. The original vessels were all sails. Remember again, they were just scoping the top of the world into the surface of the water. The bottom line is, operational fisheries oceanography has evolved, but it's all about everything that you can possibly imagine changing by the hour, by the season, and by location. The vessel in the upper right-hand corner there belonged to a wonderful master fisherman from Norway. It was able to fish any kind of fishing gear that was available. Seines, nets, all sorts of other odds and ends, and it had a mountable cannon on the bow for whaling season. He was ready. I actually took this photograph in Somalia as part of a project that was going on there. Tessellations. I've always been a historic buff. Since I was a little kid, I got caught in the adult section of the public library and my mom got called. Living in the California coastline, we know about the sea breeze. In the morning, the air is being sucked out into the ocean. In the afternoon, the heating causes it to be sucked in. That's daily. We got tides, we got all this stuff, and you work your way down this list. And you see the physical processes going on, and every biological organism also has its responses on the same time scale. The dotted line is the annual cycle, and you work your way out to geological. Now, humans are harvesters. So we take advantage of whatever the organisms are doing. And as we saw in that first graph, they come and go. And society, on the other hand, is an end-user response and has to change as all this goes on. Technological innovations have helped keep populations fed, but that's a big, long story. Life is complicated. Coping requires some major changes in how we employ what we know and admit what we do not. Tough to get people to do. Well, I spent front decade out on the ocean working in the Inter-American Tropical Tuna Commission up and down the eastern tropical Pacific, eventually evolved out into New Zealand, Hawaii, working with Japanese colleagues and Australian colleagues. And what I was basically putting on their table was what I had learned about the changes in the upper ocean, how it affects catch and effort statistics. Again, my historical background, reading, sharing information. I began doing graphic stuff a long time ago, and it started off with going to the Iceland, Greenland populations and all this stuff, and learning about the warm medieval and the amount or minimum and et cetera, and people going away, and then evolved into the 60, 70-year cycle of the herrings and other critters in the North Atlantic. What are we going to do? Well, I went to work for FAO in 1983 with my tuna physiology and open ocean background, and converged with 3 or 4 other folks, contemporaries, who were from different parts of the world. And one of them, Jorge Schirke from Peru, came in. I'd been working there for a couple of years and had a 3-year contract, and they asked me if I wanted to extend it, and I said, well, I'm not sure. And Jorge and I talked it out, and I said, well, if we can pull together an international convergence, bring the fisheries expertise from locales around the world, and put this story together, I'll sign up for another 3 years. So we worked it out, traveled into the various places, IOC, the World Bank, other places, found the funds, and we set up a meeting in Costa Rica, San Jose, Costa Rica, in 1983. 100+ people showed up, amazing personalities with stories and stuff. The Japanese fellow, Tsuyoshi Kawasaki, paid his own way in. His government wouldn't pay his route. And he arrived one evening, gave a talk before lunch the next day, and went home the next morning. But the bottom line was, and I'll point out that the meeting was in the middle of that graphic in the Japanese sardine story, we had just seen the collapse of Peruvian anchoveta and the recolonization by the sardines in South America. California's story was pretty goofy, and the Japanese had a lot of information, and their sardine was beginning to bloom again. And he went home, and we were all expecting, yeah, well, we can kind of guess what's going to happen, when the sardine will finish its peak and when it's going to fall apart again. And sure enough, by 1990, Japanese sardine had expanded all the way out to the date line, and by 1996 had collapsed back into the coastal area, and by 2000 was back to where it was in 1960, 2 little refuge populations. That was very, very revealing. His real message, and strangely enough, the important message, was the California current and the Humboldt current and the Japanese sardine bloom and bust were nearly synchronous. The North Pacific did its job. Now, if I can get this next slide to come up, will be good. That was a good idea. Okay, back it up. Okay, I spent a lot of time working with ocean data sets for a long time, and there were obvious warm and cold periods and different absolutely opposite things going on the coastlines, which is what the Japanese and Humboldt story was all about. I had a nice movie of 13 years of the Rossby waves that couldn't get to run on this machine, but that's the way life goes. The bottom line is it's never the same twice out there. Now, I got involved with the paleoclimatology group by being introduced to the Pacific Climate Conference folks back in the mid-1980s. And I met Roger Y. Anderson, who was professor of paleoclimate science, paleosedimentologist from the University of New Mexico. He had 3 generations of students from the late 50s, early 60s on, who had gone around North America and out into the world, and basically every sediment record they ever pulled up had a solar signal in it. So he was quite convinced that it was relevant. And meanwhile, William Quinn, the Oregon State University, had just released the El Nino proxy records that he'd gotten from boat logbooks and things all over the Pacific Basin, and we plotted sunspot frequency and the ENSO frequency, and he discovered that the sunspot frequency precedes the El Nino frequency by a little bit, and we were kind of inspired. We also, the next year, a colleague that I'd worked with at the Tuna Commission, Bob Francis, came and explained that his graduate student, Stephen Hare, and a colleague, Nathan Munt, would come up with a Pacific Decadal Oscillation explaining the coming and going of the salmon in the Gulf of Alaska. And a few years later, George Taylor, Oregon State climatologist, who I met at Pacific Climate Conference a decade before, pointed out that it was actually the opposite phenomenon from Columbia River down into California, so location. All of these slides, everything I'm going to be pumping out here, have hot links to all of the material that, again, we can't get some of this stuff to come up, so we're not going to worry about it. The Russian community has created an atmospheric circulation index back in the 40s, and it turns out that it's all related to pole to equator or east-west winds. And when you do the A plus B equals 1 business, it turns out this has a cycle again of about 70 years. And of course, in the last few years, we have seen that affecting our weather in through the Midwest. You've enjoyed one of the yucky winters we've had in a long time for the last couple of years, and it's going to be there for the next 15 or 20, so have a good time. I invited Leonid Kleostorin to FAO, introduce him to the folks there who wrote volumes. If you click on these when you get the downloaded file from this, you'll get access to free access from the FAO libraries. And what I did was pull all this information together, coordinate as much as I could, sent him home after he came to visit me in Monterey for 6 months with the objective of writing a book. The first step in that, working with some of these Russian math wizards and statisticians, they put the Greenland ice core record over the top of the Tsuyoshi Kawasaki sardine balloon and bus, and every time it warms, the sardines swarm, and every time it cools, they collapse. Oddly enough, they'll be able to use that for forecasting, projecting things that are going on, global temperature as well, and the book contains all this information. And what my whole point was, and what it was all about in the first place, is between the bloom and bust cycles, there's a null, or what I call a transition period, and this is when we should not be fishing very hard. And this is not built into our management system. Everything is still based on equilibrium theory, just like climate models. We've come a long way in 2,000 years. We can now access virtually all the fish in the world ocean. The Russians have been tracking, the Arctic is on their shoulders, the ice and temperature, and they can find no trend for the last 70 years. It's been back where they were in the 30s, and yet the global temperature is on its way. Their forecasts are there. They cannot give you a year-to-year forecast. They can only give you this long cycle because there are other processes going on and complex. The ice cover in the Kara Sea is a good index. Arctic temperature, ice cover in the purple bit. If you bump the ice cover back 8 years, you discover, yes, there is a thing called latent heat in the world oceans. And yep, meanwhile, keep going. Lag is what life is about. All of this material, as I say, if you download these, they're all hot links. They will take you to the free access to all of the publications involved. I have books, volumes, reports, Walter Stark's website on coral reef issues, which I'm sure you're very familiar with, that basically says, the nonsense that's been sold is nonsense. And I will kind of leave it there. The coping with climate change and basic historical experiences is on John Daly's website. It's a commentary. Many of the folks at this meeting have posted commentaries there, and it's short, semi-sweet. The bottom line is, the reason there are 7 billion of us on the planet today is we have learned to cope.